Hello viewers, in today's session we are going to discuss an important and conceptual problem from three-dimensional geometry related to plane and straight line, right? So here we have to solve this problem, that is find the equation of the plane which contains the line whose equation is x minus 1 over 2 is equal to y plus 1 over minus 1 is equal to z minus 3 over 4 and is perpendicular to this plane x plus 2y plus z is equal to 12. So now let us first understand this problem with the help of a rough diagram. Right now, see, we have to find the equation of a plane which contains this line. Right, so let us draw the plane like this. Suppose this is the plane whose equation is to be determined. Right, and let us take this plane as plane P. Right, and this plane P contains this line. Suppose this line is denoted by the capital letter L. So here we have the line L, right? And this plane is perpendicular to this plane, right? So let us call this plane as plane P1. So our plane P is perpendicular to this plane P1, and this plane P contains this line L. So now let us draw the plane P1, right? Suppose the plane P1 is like this, right? And this plane P is perpendicular to this plane P1. And remember, this is a rough diagram and not the actual diagram. So two planes are said to be perpendicular to each other if their normals are at right angles, right? See, when two planes are said to be perpendicular to each other, it implies that the angle between their normals is 90 degrees. So now let us assume that the normal to this plane P is given by the vector, say vector n, right? So vector n is the normal vector to this plane P, and let us assume that the normal vector to plane P1 is given by n1 vector, right? So let us draw the n1 vector like this, right? So this is our vector, the normal vector n1, and this plane P is perpendicular to this plane P1. It implies that this normal vector, that is the vector n, is also perpendicular to the normal vector n1. So this angle must be 90 degrees. Now let us come to the equation of the line L, right? So now see here, the equation of the line L is given in the symmetric form, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c. So now if we compare the equation of this line with the symmetric form, then we can see that x1 is given by 1, then y1 is given by minus 1, because here we have y plus 1, so it can be written as y minus minus 1, and here the value of z1 is given by 3. So it implies that this line L, it passes through the point 1 comma minus 1 comma 3, right? And moreover, a, b and c are the direction ratios of the line L. So the direction ratios of the line L are given by 2, minus 1 and 4. Now see, in the given problem we are given that the plane P, it contains the line L, right? And this point, it lies on the line L. So this point must lie on this plane P, because this line lies on this plane P. So we can take a point, say here Q, which lies on the line and this plane P, right? So this point Q has the coordinates 1 comma minus 1 comma 3. So now let us come to the equation of the plane P1, right? Now see the normal vector to this plane P1 is vector N1, and the direction ratios of the normal vector N1 are given by the coefficients of X, Y and Z. So here the coefficient of X is 1. Here we have the coefficient of y as 2, and here the coefficient of z is 1. So the direction ratios of the normal vector n1 to this plane p1 are given by 1 comma 2 comma 1. So now let us assume the equation of the plane P as ax minus x1 plus b y minus y1 plus c z minus z1 is equal to 0, right? See the equation of any plane P which passes through a point x1 y1 z1 and having the direction ratios of the normal as a, b and c, the equation of such a plane P is given by this equation, right? Now see here x1 y1 z1 is the coordinate of a point which lies on the plane P, right? And here we can see that this line L lies on the plane P, and this line L passes through this point Q, and this point Q also lies on this plane P. So let us take x1 y1 z1 as 1 minus 1 and 3. So the equation of the plane P is now given by A, and here we have x minus 1, then we have b y plus 1, and then we have c z minus 3 is equal to 0. So let us call this equation as equation number 1, and here A, B and C are the direction ratios of this normal vector to this plane P. So here we can now write direction ratios of the normal vector N as capital A, B and C. So now let us apply the condition of perpendicularity of two vectors, right? Now see this line L is contained by this plane P, right? So this normal vector must be perpendicular to this line L. That is the normal vector N is perpendicular to the line L, and the direction ratios of the normal vector are A, B and C, and the direction ratios of the line are given by 2, minus 1 and 4. So we can now have the condition that is A times 2 plus b times minus 1, then we have plus c times 4 is equal to 0, because we know that if two vectors are perpendicular and their direction ratios are a1 b1 c1 and a2 b2 c2, then the condition of perpendicularity is that a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So here a1 b1 c1 may be taken as capital A, capital B and capital C, and a2 b2 c2 may be taken as 2, minus 1 and 4. So from here we have one equation in three variables, that is 2a minus b plus 4c is equal to 0, right? And the second condition is that this plane P is perpendicular to this plane P1. So our normal vector N is also perpendicular to the normal vector N1, right? So again, applying this condition, the direction ratios of the normal vector N are A, B, C. So we have A times the direction ratios of the normal vector n1 are 1 to 1. So we have A times 1, then we have B times 2, then we have C times 1 is equal to 0, right? So again we have another equation in three variables, that is A plus 2B plus C is equal to 0, right? So now we have these two equations, and we have to solve these two equations. So now these two equations can be solved by using the method of cross multiplication, but here we'll prefer the method of elimination, right? So in the method of elimination, what we will do, we'll select any of these variables. So let us select B here, and let us equate the coefficients of B in these two equations. So let us multiply this equation by 2, because here we have minus 2b and here we have 2b. So multiplying this equation 2 by 2, we have the equation 4a minus 2b plus 8c is equal to 0, and the equation number 3 may be written here, a plus 2b plus c is equal to 0, and let us add these two equations. So these two quantities get cancelled. 4a plus a is equal to 5a, and here we have plus 8c plus c is 9c, and this is equal to 0, right? So now we can write 5a is equal to minus 9c, right? And let us introduce a scalar or a real number, say a lambda, right? So 5a is equal to minus 9c is equal to lambda, so that we can now write a and c in terms of lambda. So 5a is equal to lambda, so we can now write a is equal to lambda over 5, and from here minus 9c is equal to lambda, so c is minus lambda over 9. So let us substitute a and c in any of these two equations to get the value of b in terms of lambda, right? So now from equation 2, we can write the value of b equal to 2a plus 4c, right? So taking minus b to the right hand side, we have 2a plus 4c is equal to b. So now substituting a and c in this equation, we have 2 lambda over 5, and then here we have minus 4 lambda over 9. So let us solve this expression. So taking the LCM, we have here 45, then we have 18 lambda minus 20 lambda, right? And this is equal to minus 2 lambda over 45, right? So viewers, the value of A, B and C are now obtained in terms of lambda, and this lambda is some scalar or some real number, right? So let us substitute the values of a, b and c in equation number 1 to get the equation of the plane p. So substituting a, b, c in equation 1, we have now this equation, right? So let us throughout multiply by 45, right? So multiplying this equation both sides by 45, here we have 9 lambda x minus 1, then here we have minus 2 lambda y plus 1, and here we have minus 5 lambda z minus 3 is equal to 0. Now here we can see that lambda appears in all these three terms, and lambda is a scalar and it is a real number, but lambda is not equal to 0, right? So now we can write this equation as 9 times x minus 1, then we have minus 2 y plus 1, and then we have minus 5, and z minus 3 is equal to 0. So now let us simplify this equation. So we have 9x minus 9, then we have minus 2y minus 2, and then we have minus 5z plus 15 is equal to 0. So now we can write this equation as 9x minus 2y minus 5z, and here we have minus 9 minus 2 and plus 15. So minus 9 and minus 2 is minus 11, and minus 11 plus 15 is plus 4, right? So this is the required equation of the plane P, which contains this line L, and it is perpendicular to the plane P1.